So scalar versus vector quantities, the concept is very simple. All right, so scalar quantities are quantities that only have a value or a number assigned to them. All right, so this would be, for example, temperature, right? We don't have, there's not, when we talk about temperature, it's simply a number. All right, vector quantities are also going to have a value or a number assigned to them, but they also have a direction. So all forces are vector quantities because they have a direction. It matters the direction that they are acting, right? When we think about the force diagrams, for example, right, it's all about what direction are these forces acting, because then we know whether to say, for example, to add or subtract them. If they're acting in the same direction, we add them, all right? So the concept is quite straightforward, but usually on the test, what they like to do is they will ask you about examples of each of these, all right? So for example, when we talk about speed, you can remember this because it's SS, right? Scalar, speed is a scalar quantity, all right? Whereas the vector equivalent of that, if you will, is the velocity. So velocity, when we talk about the velocity, then we're talking about how fast something is going, but also the speed. So for example, if you have a car, right, that's moving along and it takes a turn, here, where it starts to turn, the velocity will change, but the speed, unless the car brakes or slows down, will remain constant as it goes around the turn, because the speed doesn't care what direction it's actually going in. All right, so this is one of the most common examples, speed and velocity. Okay, energy is also scalar. Okay. Vector quantities also include displacement as opposed to distance. So scalar, the equivalent, so this would be distance. And so these two are similar, and distance, the vector equivalent of distance would be displacement. It doesn't come up that often. Okay. So the thing that I want to point out with this is that most of the time you can kind of think about it and figure it out whether there's a direction assigned. But the thing to note is that if you are using velocity to do any calculations, then that means if you're using the velocity to calculate something, then whatever you're calculating is actually also a vector. So the big example of this would be acceleration. Right? If you think back to the equation that we had for acceleration here, right? You're using velocity to determine acceleration. And since this is a vector quantity, then this also must be a vector quantity, right? Speaking of which, time would also be scalar. Oops. Time is a scalar quantity, okay? So it might be a good idea to make a list of each of these so that you know which quantities could be scalar and vector. And if you're not sure, you can always email me and ask about it.